welcome back to the third lecture of Signal and System. I'm Ayushi Sarkar and going to continue with your Signal and System basic lectures. I hope you remember what I have made you study on the last previous two lectures, and if not, then I would be just giving you some brief, and then I would be continuing with the today's topic, even and odd signals. So before moving to the even and odd signal, let me figure it out what is there in last previous lectures. So I have basically taught you about the shifting, scaling as well as reversal, and when I am taking this forward to the third lecture today, there I would be teaching you what is even and odd signal. So I hope you remember what was time reversal. So if not, then I will be continuing over here, so you don't have to make any kind of previous notes, so you can continue with me as well. So today's topic is even and odd signal. Yeah, this time I'm taking some different approach. Previous two lectures, I have already made the notes and just brief it over here, but this time I will be making notes with you guys so that you can continue making your notes with me, and you will find one thing very easily, that you can continue making your notes as well as you will be having a age to learn with me as well. So let me cover up your topic, even and odd signal. So even and odd signal. So what actually, when we think about the time reversal, when we do time reversal, we get some symmetry according to the signal. Just what do I mean to say? I actually mean to say that do time reversal, we get a symmetry of signal. When we do time reversal, we get a symmetry of signal. So this symmetry of signal basically defines how the signal is going to be even or odd. So if this symmetry is identical, then we call it as even signal. And if this symmetry is non-identical, then it is actually odd signal. So okay, let me figure it out each and everything with equations as well, so that it would be clear for you. So let me tell you first about the even signal. So even signal, what do you understand by even signal? Okay, if you remember that I have already told you that when what is even signal, and even signal is basically depending on the folding or the reflection of the signal, and it is not changing. Basically, when the signal remains identical under folding means basically time reversal. Okay, I hope you remember. When I will give example, you will get to learn it more easily as well. Under folding operation, okay, so that means this folding operation means basically time reversal or reflection. Okay, so just give me a normal example. I am giving you one example of the just think about something, any signal that is giving a property which is, see, the equations are always going to be important, so mark the equation very well. When we are doing xt, okay, we are doing time reversal t dot r, okay, and here it comes with x minus t. Okay, but this x minus t is equals to xt. So here when I am telling you this property, just please note it down. This is very important. Like, it's the best thing you can remember for yourself. So after seeing this, what comes to your mind first? The basic example, the equation wise example. For me, the equation wise example that comes first in my mind is that whenever I look at it is cos theta. You know why? Because when we take cos minus theta, okay, it gives you cos theta, isn't it? So the basic example of it is going to be our when cos omega t See, when we are taking cos omega t and doing the time reversal, and it is coming as cos of minus omega t and giving rise to cos omega t. So it is a basic example of even signal. Otherwise, you can just draw another signal as well. So I'm giving you another example that is going to be, wait, let me draw it for you. Here I took one y-axis. Okay, this is our y-axis. The axis is axis. Okay, so here this is a triangle basically around this. Okay, this is our minus a and this is our a, positive a, and here comes our normal amplitude a. So here xt. Whenever I will do x of minus t, this will remain exactly same. How it will remain exactly same? You know what? When I will do x of minus t, it will never going to change this figure. This is always going to be same. This is the figure, it will remain same. Okay, because this is actually symmetric against this y-axis. So always remember, when it is an even signal, signal must be signal is symmetric against y-axis. Okay, so this is one example. Another example I am taking for you. Let me take this example. See, this is another example. So I am taking, this is our xt. Sorry. Here comes our xt again. This time again the same symmetricity I am giving. Okay, this is our xt, but this is our, when I will do this x minus t, this will remain same, because this is also a, this is also minus a, and this amplitude is going to be our, suppose a. Okay, this is the basic example. So just keep this point in mind. This is a highlighting point I am telling you. This is a very highlighting point, that signal is symmetric against y-axis. Okay, this is very much highlighting point. So this is all about even signals. I hope it is clear. And the most important thing, again I am telling, x minus t is equals to xt. This is the one of the main property that you have to keep in mind. I won't be taking you further if you won't understand this. So if you have problem, just repeat the video and continue with the lecture. So once I complete this, I will be moving to the odd signal. So what is odd signal basically? So when I am talking about the odd signal, here comes our odd signal. When I am talking about odd signal, what is this odd signal? Odd signal mean which is not identical. So it doesn't remain identical while doing time reversal. Okay. Under folding, operation, or time reversal, or reflection. So what is the equation for it? If I am going to write the equation for it, that means xt while converting to time reversal t dot r, x minus t is obviously not equals to xt, and one more point is that x minus t, sorry, wait ahead, x minus t should be equals to minus of xt, or x minus t, or xt should be equals to minus of x minus t. Okay, so this is the very important sort of thing. Okay, So once you keep this thing in your mind, so I'd be moving with one of the most important property. Okay, so I would be moving with the very important property of odd signal. What is that? So the property is that when we take a time t is equals to 0. So just put it here 0. Once I put it here 0, the whole signal is going to be 0. That means once it has no changes, basically at time is equals to 0, there is going to be 0 DC value, or you can say odd signal will have 0 value. So we can write the property over here. X0 is going to be minus of x minus of 0, and here once I continue with it, x0 is going to be minus of x0. Okay, so finally you can conclude what? In time t the signal is going to be 0. Simple and sorted. Okay, so this is one of the most important property, and you can write it in a simple words as well. What are you going to write over here? If you are writing, we can say that when t is equals to 0, the odd signal is going to be 0. And second point, what you are going to write, another point is that average, okay, mean or DC value of any odd signal. Very important, this is the terms mean value, DC value and average, okay, of any odd signal is always gonna be 0. Okay, so this is where I conclude over here. So this is the thing. So just give me an example of it. So the first example that comes to your mind after seeing this cos, I think it is going to be sine. Because do you remember what we take as sine? When I tell you about the sine, this is sine omega t doing the time reversal tr. It is going to be our sine minus of omega t, which is basically equals to minus of sine omega t. I think this resembles this, right? So you can conclude that this is a basic example of odd signal. I hope you understand it from here, and if you want to see any kind of picture of it, then I can give an example as well. Here I am drawing an odd signal for you, because I want to complete this whole thing in a single slide. That's why drawing it over here. Otherwise I could have taken another slide for you. See, this is our basic signal. Okay, this is our signal. Once I have this signal, this is our xt, right? This is our t. But when I'm going to draw x minus t, okay, it would be basically anti-symmetric. See, this is going to be the x minus t wala signal. Got it? So this is our anti-symmetrics to y-axis. So basically odd signals are anti-symmetric to y-axis. This is our anti-symmetric to y-axis. I hope it is clear. I have taken a long time to make you understand this very basic topic. So I hope I would be continuing with the next topic, which is basically the summation topic. You know what? Any signal is never a completely odd, or never it is completely even. So basically a signal, when we draw xt, suppose, okay, xt is basically a summation of, xt is basically the summation of xet, that means even component of the signal, plus xo subscript t, that means odd component of the signal. So once I further continue with this topic, basically I will be continuing with here, and then just wait a second while I move to the next slide. So here I come back with the topic, the properties of odd and even signal. So what was I telling you? That a single signal, that is xt, suppose it contains of both the components, the even component as well as odd component. How do you determine which is and how much is the even component and how much is the odd component? So you will determine it by seeing the signal, it is even or odd firstly. So let me figure it out. Just give just give me a second. I will draw a signal for you. I think it would be helpful. So once I draw a signal, this is the signal. Wait, sorry. This is our signal, okay. Suppose this is our signal. Okay, so once I draw this signal, this is our xt. When I will draw x minus t, what do you think the outcome will be? It would be x minus t is going to be this, right? So when I get this as x minus t and this is our 10, suppose this amplitude is going to be our 10. Okay, so I will give you the formula as well. Through the formula you can also determine, or easily you can determine by this short trick which I am using it over here. So you can see that this is our x0, right? This x0 t, x naught t basically, which is x naught t is going to be our 0. Okay, that is our odd component, because this is not a odd signal, this is the even signal, because this is symmetric against this y-axis. So again I am telling this is symmetric against y-axis, that's why we are taking this. And the even component is definitely going to be 10, because we are just getting this component in just this side, nothing more. So finally we can say in simple words that the DC value will have only even signal, because we are just cutting out the odd signal. Okay, and if you want to check it through our normal, means like simple way, I will tell you that if you want to check it in a formula, so please note down the formula. I'm writing it in a different color so that you can identify what is the formula. So formula for even component, that is going to be x e subscript t, that is equals to 1 by 2, okay, xt plus signal after the time reversal. I mark my words again, after the time reversal. This is the formula. And how do you put this in formula? See, just half. What is this? This is 10, right? You just put it over here, 10. You do the time reversal. After doing time reversal, does the sign is getting changed? This is the even signal. No, right? So you will put it over what? 10. So 10 plus 10 is going to be 20. 20 divided by 2 is going to be 10, which is equals to nothing but the even signal. I hope this is clear and proven. And if I take the odd signal, okay, let me take the odd component for you. XO subscript t, which is equals to half our signal, initial signal, minus of, see I am marking my word, this is after the time reversal of the signal, okay, this is going to be our x of minus t. Okay, so here when I come to this point, this is our 1 by 2, sorry, let me take this different color, okay, 1 by 2. xt is what? xt is nothing but our 10. As this is the even signal, the value of this x minus t is going to remain same. So this is also 10, right? And the sign between this is going to be minus. So here I put a minus sign and it turns to be 0. I hope now it is very much clear to you that how am I doing this odd and even component, right? This is the first property. Okay, this is the first property. Keep this in mind. These two formulas are very much important. Property 1. Okay, then I would be moving to the next property, which is basically, see, when I move to the next two properties, it is having two basically subsequent properties which I have already taught you. Basically remember, this is the most important highlighting point that I have already taught you. Okay, this is the highlighting point. So please remember that a normal general signal is always having a component of both even as well as odd. So when I'm telling this, I'm moving to the second property. Sorry, my bad. Property 2. What is the next property? So basically here the DC value was even. So let me take the DC value again for you. DC value which is going to be even, plus I am adding a even signal with it. Even. Okay. So what does it is giving me? So for example, I mean to say that, suppose I am taking means like example, let's say here it is 10, right? The DC value was 10. 10 plus I am taking a even signal, that is going to be our t square. Okay, p square. Okay, p square. Okay, so if I am taking this p square is basically what? When I am taking this p square, this is basically x p. Okay, so when I am taking this as xp, here I take xp. Okay, and if I do time reversal tr and translating as x minus of p, what is giving me? It is giving me 10 plus minus of p's whole square. Ultimately, what is it giving me? It is basically giving me the same thing. So it is nothing but when I am taking x minus p, this is basically equals to 10 plus p square, because this minus will not have any kind of effect in it. Simple. So this is our identical signal, right? So this is our xp. That means what do you get from here? When we add any DC value which is basically even in the form, and we are adding a even signal with it, we are getting a even signal. This is one property. Okay, let me take another property for you. These are quite similar, right? Property third property is that when I'm taking the again even DC value, okay, this time the DC value is even, so even DC value plus a odd signal, what is going to give me? See, again I'm going to take the example. This time I would be taking, you know why this is p square is going to be identified as even? Because whenever we take anything like -1 and we are doing square of it, it is giving us again the same sort of stuff 1. Okay, so ultimately this is a even signal. I hope you understand, right? So I'm not explaining it much because you are not kid. 10 plus p cube this time, because we take -1's cube and we are getting what? -1 cube, and when we are doing it we are getting as -1, not 1, right? So minus, this is our xp, this is our odd signal p cube. Okay, so I am doing what? I am doing time reversal. Okay, simple time reversal, and I am doing what? X of minus p, and there comes our 10 plus minus p cube. Okay, which is basically identified as 10 minus p cube, which is c, which is not equals to minus of xt. Okay, very important point. See, this is our xp, right? This is our xp, which is, this is our xp, right? This is not equals to minus of xp, nor it is equals to xp. So what can you conclude from here? You can simply conclude one thing, that this is not an odd signal, right? This is neither odd neither even signal. Okay, this is neither odd nor even signal, and this is the generalized form of any kind of signal. We are taking DC value as even plus this is the odd value, so we are getting a generalized value. So please, I would request you all to write another point along with me, which is any generalized form of signal is definitely expressed as the form of odd and even component which is proven over here, right? This is the normal generalized proof. Okay, so when I move to the next, means like here I have told you about the addition, let me take you to the multiplications as well. So what do you think about the multiplications? So as I am telling you that when I am talking about the multiplication and third property, I think fourth, right? Yeah, this is the fourth property. Okay, so this is the fourth property. So when we are doing multiplications, I am making a chart for you. Okay, so let me multiply even signal with a even signal. What do you think it will going to give you? This is our A. See, even signal t square is a even signal, right? And when we multiply with another even signal, let's say the another even signal is going to be t to the power 4. So what is going to give us? We know when we means like multiply two things which are having like the powers with the same value t. Okay, so we are just doing what? T to the power 6. We will add the powers. So what is this t to the power 6? This is definitely a even signal. So when we multiply two even signals, we are definitely going to get a even signal. Okay, let me take you to the next example. When we multiply two odd, okay, what are we going to get? T to the power suppose 3 like last time. Okay, and again we are getting what? To the power 3, and here I take t to the power 5. This is also odd, right? And we are getting what? T to the power 8. So what? This is the even signal. Even see, when we are doing multiplication of a odd signal of two odd signals, we are getting what? Even signal. Okay, we can conclude it from here. And the third one, see, when we take one odd signal and another even signal, what do we get? I think now you have already cracked the thing. T cube, and I am taking even signal is t square. This is our t to the power 5, right? And this t to the power 5 is our odd. Okay, here this is odd. So this was easy squeezy. Okay, so let me take you to the, I think the means like not the last property, last two things. One is our normal differentiation. Okay, what do we do while doing differentiation? So let me give you the overview. So our property number 5. What is the fifth property? When we do differentiation, d by dt of any kind of even signal, okay, is going to give me what? So just let's do what? Let me take an example, then I will make it clear to you. Otherwise you will just muggle up things and you will not understand what's going on over here. So let me take an example of like d by dt of even signal. So what was it? It was going to be basically our value. I am taking another d by dt of even was t to the power 4. Okay, so what do we do? 4 t cube. This is what? This is our odd signal. So when we differentiate any even signal, we get a odd signal. Okay, this is our odd signal. Okay, but there is always a but when we take DC value. So when we do this, like when we take DC value, I am writing it in different color, okay, so that you can identify. When we take DC value, which is basically what? Constant. DC value is always constant, right? Like 10, 20, whatever it is. So when we do is as d by dt, and this is our DC value, we get what? This is our 0. And 0 is what? 0 is neither even nor odd. Okay, why am I writing like this? I could write just like this way. This is not even not odd. Okay, so this is another exception. So we don't focus on exceptions much. Let me take you to another things. So after this, when we take like same way, we are doing d by dt of any odd signal. Okay, odd. Do we get even? I think yes. I hope you cracked it. D by dt of any, like t to the power means like 3, and we are getting it as 3t square, and this t square is obviously going to be a even signal. Okay, I hope it is clear and no doubts with the DC value. And once I go for the integration part, that is going to be our property number 6 and last property for today, which is our property 6. Sorry, I have changed the color of the pen. Yes, property 6. This property 6 is going to be integration. Okay, when we integrate any even signal, I hope you understand, because in case of differentiation, what do we do with the powers? We just deduct -1, but in case of integration, we just add 1. So it is very simple to understand that if I am going to have, like, let me take another t to the power 4 dt. Okay, this is our odd, and here what we will get? We will get t to the power 5 divided by 5, right? So this is our obvious word, this is our odd. Fine, simple thing. I think these are the very quick summarized sort of thing once you get the gist of it, how I am playing with the powers. So I am doing what? Odd signal dt, and definitely I am going to get even, right? I hope you understand. Still I am going to give you example as it's my duty. So here I come with t to the power 4 divided by 4, and this is our even. Okay, now you will tell me that what is going to happen in case of the DC value. So this time we don't focus on DC value. Let me take another, let me give you another thing as well. What we do in case of reciprocals, basically, we basically take reciprocal property number 7, which is 1 by odd is going to be always odd, and 1 by even is going to be even. Okay, these are the even. So this is the complete sort of properties that I'm going to make you understand about the even or odd, and I'm going to keep this lecture as small as it is. I hope you understand. I have covered this overall odd and even signal and their properties in this lecture. And yeah, again, I'm very sorry because I couldn't upload last week's lecture. So this is first lecture of this week, and I'll be continuing the next lecture. So thank you for watching, and bye bye. Let's meet you on the next lecture, and don't forget to give me the feedback as well where I should improve myself. Bye bye.